Hello friends, in this session I explain a priori and frequent pattern growth algorithm with example. We know happy growth algorithm and a priori algorithm. They both are used for mining frequent items for Boolean association rule. In data mining, finding the frequent patterns from large database is being a great task and many researchers is being undergone continuously. We know classical frequent pattern mining algorithms that use candidate set generation and test, which is used in a priori algorithm, and the algorithm without candidate set generation, which is known as happy growth algorithm. A priori algorithm discovers the item set which is frequent. Then all of its subset must also be frequent. A priori algorithm generates candidate item set and tests if they are frequent. Epigrowth techniques use pattern fragment growth to mine the frequent patterns from large database. A extended prefix tree structure is used for storing crucial and compressed information about frequent patterns. Epigrowth discovers the frequent item set without candidate item set generation. Now, I explain how does a priori algorithm works or its steps. First step is find out the minimum support from the database or given example. In general, minimum support is given in digit, but if minimum support is given in percentage, then we have convert that support into digit with below equation. So equation is minimum support is equal to given minimum support, which is available in percentage into total transaction divided by 100. I explain with this example. For example, support threshold is 50 percentage and total transaction is 6. For that, minimum support is 3. Now, in second step, create a frequency table of all the items that occurs in all the transaction and their count. Now, in third step, create a new table in which we have include those elements or items are significant for which the support is greater than or equal to the threshold support. I explain these steps with example. For example, in step 1, we have find out minimum support is 3. So, only those items are significant which occurs in more than 3 times in the transactions. Now, in step 4, make all the possible pairs of the significant items. Means for that the order doesn't matter. Means we can write AB is same as BA. Now in step 5 we have count the occurrence of each pair in all the transaction. Now in step 6 we have create a new table of those item sets are significant which cross the support threshold. Now in step 7 we have create to find a set of 3 items that are purchased together as well as their count. We will use the item set found in step 6 and create a set of 3 items. Now in step 8 we have create a new table of those item sets are significant which cross the support thresholds. Find out a set of items and their counts till the frequent item set for the given transaction is not found. Then after we have find out confidence of that frequent item sets. Now I explain numerical example of a priori algorithm. Seeing this table, we have 9 transactions like transaction T100 to T900 and list of items like in transaction T100 that includes items I1, I2, I5. In 200 transactions, they include I2 and I4 items. In transaction 300, they includes T2 and I2 and I3 items. In transaction T400, they includes I1, I2, and I4 items. In transaction T500, they includes I1 and I3 items. In transaction T600, they includes I2 and I3 items. In transaction T700, they includes I1 and I3 items. In transaction T800s, they includes I1, I2, I3, and I5 items. And in transaction T900s, it includes I1, I2, and I3 items. For this example, support threshold is given 22% and confidence is given 75%. Now I explain solution for a priori algorithms. So first we apply step number 1. In step 1, we have find out minimum support for the database or given example. In this example, support threshold is given 22% and total transaction is 9. So put that value in equation like our equation is given minimum support which is available in percentage into total transaction divided by 100. So in this example, our support threshold is 22% and total transaction is 9. Put that value in this equation. So we have like 22 into 9 divided by 100. So we have find out the answer is 2. So our minimum support is 2. Now in next step, we have to scan the database to find the occurrence of the item set in the database. Means now based on the given table, we have find out individual item with their count. Like count of each item, like item I1 occurs 6 times in the original table, like I1 occurs in transaction T100, 400, 500, 700, 800, and 900. Similarly, I2 occurs in transaction 100, 200, 300, 400, 600, 800, and 900. So this way we have find out I3 occurs 6 times, I4 occurs 2 times, and I5 occurs 2 times. Now, in step 3, we have create a new table in which we have include those elements or items are significant for which the support is greater than or equal to the threshold support. So, based on the main transaction table, we have find out individual items and their counts. Like this, I1 occurs 6 times, I2 occurs 7 times, I3 occurs 6 times, I4 occurs 2 times, I5 occurs 2 times. Now, remember, I said the item is said frequently purchased if it is purchased at least 2 times. So in this step, we have removed all the items that are purchased less than 2 times for the table, and we are left with so. So we have find out these new tables like I1 occurs 6 times, I2 occurs 7 times, I3 occurs 6 times, I4 occurs 2 times, I5 occurs 2 times. So in this table, we cannot prove any item because all the items minimum support is equal to or greater than minimum support. Now, in step 4, we can make all the possible pairs of the significant items. For that, we have items like I1, I2, I3, I4, and I5. And we have generated a pair of that items. For generating a pair, we have start with items I1 to I5. So it generates pair like I1, I2, I1, I3, I1, I4, and I1, I5. Then we have start with second items like I2, I3, I2, I4, I2, I5. This process is called a joint step of two item sets. So we have create a pair like I1, I2, I1, I3, I1, I4, I1, I5. Then I2, I3, I2, I4, I2, I5, I3, I4, I3, I5, and I4, I5. Now in step 5, we have count the occurrence of each pair in all the transaction. Now see our original table, trans original transaction table. Based on that transaction table, we have find out count of two items at pair, which we have find out in step number 4. Now we count how many times each pair is purchased together. So we got count of occurrence of each pair like I1, I2 occurs 4 times, I1, I3 occurs 4 times, I1, I4 occurs 1 times, I1, I5 occurs 2 times, I2, I3 occurs 4 times, I2, I4 occurs 2 times, I2, I5 occurs 2 times, I3, I4 occurs 0 times, I3, I5 occurs 1 times, I4, I5 occurs 0 times. Now, in step number 6, we have create a new table of those item sets are significant, which cross the support thresholds. Now, seeing table, this table we have created in step number 5. Now, we have proven the table with golden rules to the rescues. Remove all the items pair with number of transaction is less than 2. And we have left with pairs like I1, I2, their count is 4. I1, I3, their count is 4. I1, I5, their count is 2. I2, I3, their count is 4. I2, I4, their count is 2. I2, I5, their count is 2. Means in this step, we have removed those items their minimum support is less than 2. So we can include only those items that count is equal to 2 or greater than 2. Now in step 7, we have find out a set of 3 items that are purchased together as well as their count. Now Based on the step 6, we have these items like I1, I2, I1, I3, I1, I5, I2, I3, I2, I4, I2, I5. Now, based on that table, we have created 3 item sets. To make the set of 3 items, we need one more rules, or we can say it's termed as self-join. It simply means from the items pairs in the table, we find 2 pairs with the same first alphabets or digits. So we have get I1, I2 and I1, I3. So with the help of this, we have generate I1, I2, I3. And next is I1, I2 and I1, I5. This gives I1, I2, I5. Then I2, I3 and I2, I4. This gives I2, I3, I4. Then I2, I3 and I2, I5. This gives I2, I3, I5. Now we have find out how many times I1, I2, I3 are purchased together in original table and same for the others. Then we have get the following pruning tables like items sets like I1, I2, I3 and I1, I2, I5. There occurs 2 times and rest of the pair count is not fulfill the minimum support, so we can remove it. So our frequent item set is I1, I2, I3 and I1, I2, I5. Now we have generate association rule for the frequent item set is I1, I2, I3. Means we have find out confidence of that item set with confidence equation like confidence A implies B is equal to support A union B divided by support A. So our first pair is I1, I2 implies I3. Now see the equations. In this equation, A is I1, I2 and B is I3. Now put that value in this equation. So confidence is equal to support A I1, I2, I3 divided by support I1, I2. Now we have put the value of I1, I2, I3 and I1, I2. So number of I1, I2, I3 occurs together is 2 times and I1, I2 occurs 4 times. So answer is 50% here. We have multiplied the answer with 100 because we have find confidence into integer value, not in decimal. Now next is I1, I3 implies I2. Now put that value in confidence equations. So confidence is equal to support I1, I2, I3 divided by support I1, I3. Now put the value. So 2 divided by 4 into 100. So answer is 50%. Now next is I2, I3 implies I1. So confidence is equal to support I1, I2, I3 divided by support I2, I3. So answer is 50%. Now next is I1 implies I2, I3. So confidence is equal to support I1, I2, I3 divided by support I1. So answer is 33%. Now next is I2 implies I1, I3. So confidence is equal to support I1, I2, I3 divided by support I2. So answer is 29%. Now next is I3 implies I1, I2. Now confidence is equal to support I1, I2, I3 divided by support I3. So answer is 33%. Now we have generate rule for frequent items is I1, I2, I5. So first is I1, I2 implies I5. So confidence is equal to support I1, I2, I5 divided by support I1, I2. So answer is 50%. Now next is I1, I5 implies I2. So confidence is equal to support I1, I2, I5 divided by support I1, I5. So answer is 100%. Now next is I2, I5 implies I1s. So confidence is equal to support I1, I2, I5 divided by support I2, I5. So answer is 100%. Next is I1 implies I2, I5. So confidence is equal to support I1, I2, I5 divided by support I1. So answer is 33%. Now next is I2 implies I1, I5. So confidence is equal to support I1, I2, I5 divided by support I2. So answer is 29%. Now next is I5 implies I1, I2. So confidence is equal to support I1, I2, I5 divided by support I5. So answer is 100%. So this way we have find out confidence with these two pairs. So in this example, confidence is given 75%. This shows that the association rules are strong because minimum confidence is given 75%. So our final pattern is I1, I5 implies I2, I2, I5 implies I1, and I5 implies I1, I2. So I hope you can understand how a priori algorithm is work. Now I explain frequent pattern algorithm steps. The frequent pattern growth method lets us find the frequent pattern without candidate generation. Let us see the steps followed to mine the frequent patterns using frequent pattern growth algorithm. So in step 1, we have to find out the minimum support from the database or given example. In general, minimum support is given in digit, but if minimum support is given in percentage, then we have convert that support into digit with below equations. So equation is minimum support is equal to given minimum support which is available in percentage into total transaction divided by 100. I explain this with example like for example support threshold is 50% and total transaction is 6. And we have put this support thresholds and total transaction in our equation, so we have find out minimum support is 3. Now next step is to scan the database to find the occurrence of the item set in the database. This step is the same as the second step of a priori. The count of one item set in the database is called support count or frequency of one item set. Now, the next step is prioritize the item, or we can say priority the items. Means we have give the priority of each item according to its frequency of occurrence. At the same time, we have opportunity to drop the items which not fulfill the minimum support requirements. Now, next steps is order the items table according to priority. Means we can order items column. All the items are queued according to its priority, which mentioned in the earlier steps. Now, next step is to construct the FP tree. For this, create the root of the tree. The root is represented by null. Now, next step is to scan the database again and examine the transactions. Examine the first transaction and find out the item set in it. The item set which the maximum count is taken at the top. The next item set with lower count, and so on. It means that the branch of the tree is constructed with transaction item sets in descending order of count. Now, then the next transaction in the database is examined. Then the item set are ordered in the descending order of count if any item set of this transaction is already present in another branch. For example, in the first transaction, then this transaction branch would share a common prefix to the root. This means that the common item set is linked to the new node of the another item set in these transactions. Also, the count of item set is increment as it occurs in the transactions. Both the common node and new node count is increased by 1 as they are created and linked according to transactions. Now, the next step is to mine the created FP tree. For this, the lowest node is examined first, along with the links of the lowest node. The lowest node represents the frequency patterns length. From this, traverse the path in the FP tree. These paths or paths are called a conditional pattern base. A conditional pattern base is a subset or sub-database consisting of prefix paths in FP tree occurring with the lowest node, or we can say suffix. Then next step is construct a conditional FP tree, which is formed by a count of item sets in the path. The item sets meeting the threshold support are considered in the conditional FP tree. Now, next step is frequent patterns are generated from the conditional FP tree. Now, I explain numerical example of FP growth algorithms. So, which example we have seen in a priori algorithm, the same example I can explain in FP growth algorithm. So, similarly, we have 9 transactions. The transaction is T100 to T900. Similar item sets which we have seen in a priori algorithms, the same item sets is occurs in this transaction table. So for this example, support threshold is 22% given and confidence is 75% given. Now I explain solution of FP growth algorithm. So step 1, we have find out the minimum support from the database or given example. In this example, support threshold is given 22% and total transaction is 9. So put that value in equations in find out the minimum support. So equation is given minimum support which is available in percentage into total transaction divided by 100. So in this example, support threshold is 22% and total transaction is 9. Put that value in equation. So we have find out like 22 into 9 divided by 100. So answer is 2. So minimum support is 2. Now I explain step number 2. In step 2, we have scanned the database to find the occurrence of the item sets in the database. Now, based on the given table, we have find out individual item with their count, like count of each items, like I1 occurs 6 times, I2 occurs 7 times, I3 occurs 6 times, I4 occurs 2 times, I5 occurs 2 times. Now, in next steps, We have prioritized the items, means based on the original table, we have find out individual items and their counts. Like I1 occurs 6 times, I2 occurs 7 times, I3 occurs 6 times, I4 occurs 2 times, I5 occurs 2 times. Now we have sort the items in descending order. So it looks like I2 occurs 7 times. It is our first item. Then second item is I1 that occurs 6 times. Then I3 that occurs 6 times. Then I4 that occurs 2 times. Then I5 that occurs 2 times. So our first item is I2, then I1, then I3, then I4, then I5. Now, in the next steps is order the items table according to priority. Means we can order items column. All the items are queued according to its priority, which mentioned in the earlier steps. So final table according to priority looks like in transaction T100, the first item is I2, then I1, then I5. In transaction T200, first item is I2, then I4. In transaction T300, first item is I2, then I3. In transaction T400, first item is I2, then I1, then I4. In transaction 500, first item is I1, then I3. In transaction T600, first item is I2, then I3. In transaction T700, first item is I1, then I3. In transaction T800, first item is I2, then I1, then I3, then I5. In transaction T900, first item is I2, then I1, then I5. Now, I explain, combine our step number 5 and 6. So it for build FP tree. Now see our original table. Based on that, we have created a FP tree. For that, we have start with first transaction. Consider the root node null. Our first transaction is I2, I1, I5. Note that all FP tree that have null node as a root node. So draw the root node first and attach the items of row 1, like T100 transaction that includes I2, I1, I5, which contains 3 items, I2, I1, I5, leads to the construct of the first branch of the tree with the 3 nodes. I2, their count is 1, I1, their count is 1, and I5, their count is 1, where I2 is linked as a child of the root. I1 is linked to I2, and I5 is linked to I1. Now, in second transaction, T200 contains the items I2 and I4, which would result in a branch where I2 is linked to the root and I4 is linked to I2. However, this branch would share a common prefix I2 with the existing path of T100 transactions. Therefore, we instead increment the count of the I2 node by 1 and create a new node I4. Their count is 1. So, which is linked as a child of I2. Their count is 2. Now, the next transactions T300 contains the items I2 and I3, which would result in a branch where I2 is linked to the root and I3 is linked to I2. However, this branch would share a common prefix I2 with the existing path for transaction T100. Therefore, we instead increment the count of I2 node by 1 and create a new node I3. Their count is 1, which is linked as a child of I2. Their count is 3. Now, the next transaction is transaction T400 that contains the items I2, I1, and I4, which would result in a branch where I2 is linked to root, I1 is linked to I2, and I4 is linked to I1. However, this branch would share a common prefix I2 with the existing path of transaction T100. Then we have increment the count of each item. Now the next transaction is transaction T500. It contains the item I1 and I3, which would result in a branch where I1 is linked to the root and I3 is linked to I1. Then we have increment the count of each items. And the next transaction is transaction T600 that contains the items I2 and I3, which would result in a branch where I2 is linked to the root and I3 is linked to I2. However, this branch would share a common prefix I2 with the existing path for transaction T100. Then we have increment the count of each items. Then the next transaction is transaction T700 that contains the items I1 and I3, which would result in a branch where I1 is linked to the root and I3 is linked to I1. Then we have increment the count of each items. And the next transaction is transaction T800 that contains the items I2, I1, I3, and I5, which would result in a branch where I2 is linked to the root, I1 is linked to I2, I3 is linked to I1, and I5 is linked to I3. However, this branch would share a common prefix I2 with the existing path for transaction T100. Then we have increment the count of each items. Now, the next transaction is transaction T900 that contains the items I2, I1, and I3, which would result in a branch where I2 is linked to the root, I1 is linked to I2, I3 is linked to I1. However, this branch would share a common prefix I2 with the existing path of transaction T100. Then we have increment the count of each items. So I hope you can understand how we can generate a happy tree. Now I explain step 7 to 9 combination for construct a conditional happy tree and find frequent patterns and generate from the conditional happy tree. Now see the final happy tree which include all the transaction. So we first consider I5 item, which is the last item rather than the first. I5 occurs in two branch of the happy tree. For the see the figure, the occurrence of I5 can easily be found by following chain of the node link. The paths from by this branch are I2, I1, I5, and their count is 1, and I2, I1, I3, I5, and their count is 1. Therefore, considering I5 as a suffix, its corresponding two prefix paths are I2, I1, their count is 1, and I2, I1, I3, their count is 1, which from its conditional pattern match. Its conditional happy tree contains only a single path like I2, Chem2, and I1 jump 2, and I3 is not included because it support count of 1 and it's less than the minimum support count. So the single path generates all the combination of frequent patterns like I2, I5 jump to I1, I5 jump to. Okay, or we can write combination of two like I2, I5, sorry, I2, I1, I5 jump 2. If we can write, otherwise we can write like I2, I5 jump 2 and I1, I5 jump 2 is ready for the answer. Now for the I4, it's two prefix parts from the conditional pattern base like I2, I1 and their count is 1, then I2 and their count is 1, which generates a single node conditional arbitrary like I2 and their count is 3. Sorry, 2. And drive one frequent patterns like I2 and I2, I1 jam 2. Notice that although I5 follow I4 in the first branch, there is no need to include I5 in the analysis here because any frequent pattern involving I5 is analyzed in the examination of I5 transactions. So similarly, the above analysis, I3's conditional pattern as is I2, I1 jump to I2 jump 2 and I1 jump 2. A jump is means their count. Its conditional arbitrary three branches like I2 and their count is 4. Then I1 their count is 2 and I1 their count is 2 as shown in figure, which generates a set of patterns I2, I3 and their count is 4, I1, I3 their count is 4 and I2, I1, I3 their count is 2. Finally, I1's conditional pattern base is I2 and their count is 4, whose AP tree contains only one nodes I2, their count is 4, which generates a one frequent patterns I2, I1, their count is 4. Now, for I1, it's one prefix part from the conditional pattern base, and there is I2 and their count is 4, which generates a single node conditional AP tree where I2 their count is 4 and drives one frequent patterns like I2, I1 their count is 4. So I hope you can understand the frequent pattern growth algorithm. Thank you friends for watching this video. I hope you can understand how a priori and frequent pattern growth algorithm work. Thank you.